So our quiz problem is the truss shown. There's going to be 5 members in that truss. You all see there's a single load on it, and you're asked to find the reactions down there at pins C, D, and E. So let's start by drawing a free body diagram. And so all I need to do is just take away the external supports down there at the pins. So that leaves us with a structure that looks like this. Let's put some dimensions on it. 8 feet, 8 feet. Down there is 8 feet. And I'll use red for the external support forces. Or at C, we've got translational restraint. So F1, F2, two perpendicular forces. Same thing at D, F3, F4. And then also out there at E, two perpendicular forces. We'll call them F5 and F6. So as you count these up, we have 6 external unknowns on our free body diagram. So this would be externally indeterminate. We have more than 3 external unknowns on our structure. So we're told that this is a truss structure, but even if we weren't told that, we would see that we have a bunch of pins. We've got straight members and loads only that occur at those pins. So all members here are 2-force members. So what we're going to end up doing then is creating more free body diagrams by cutting our structure apart. So I could take the blue saw, I can cut out joint A. So it's going to give us right down here A. And what I've exposed then would be 2 internal forces. I'm going to call this PAC. That goes from A down there to C. And then I'll call this PAB. So we've got right there member AB, which also has an internal force in it. So because it's a 2-force member, we only have internal axial force because it's a straight member. So I'm also going to highlight down here joint C, which has F1, F2, and then also I'm going to draw it in tension, the internal axial force in member AC. So we're going to start over here with the free body diagram for A. So if I sum forces in the X direction, I'm going to go ahead and call positive to the right. That's going to tell me that PAB, and that's the only force in the X direction, is equal to 0. We're also going to find if we sum forces in the Y direction, we would find that PAC equals 0. So AB and AC are equal to 0. We're going to call then member AC and AB 0-force members. So we can now move over here to joint C. We've already found down here when PAC equals 0. So that equals 0. If we sum forces in the X direction equal to 0, that's going to tell us F1 is equal to 0. And sum of the forces in the Y direction equals 0. That's going to tell us that F2 equals 0. So we've actually found 1/3 of our answer. We found the answer for the pin forces at C. So what we're going to do is take this free body and I'm going to redraw it, except we know that we have 0 force in those 2 members and we've got 0 reactions. So we're just going to redraw it down here. And what we have is F3, F4, F5, and F6. So that's actually what our free body diagram now looks like. So although we're still externally indeterminate, we can use this to solve for some of the unknowns. So why don't we just do this? Why don't we sum moments, and this is at D, at point D. When we do that, we've got to get 0. And so the only force that contributes would be F6, and it would have a lever arm of not 18 but 8 feet equals 0. That would tell us that F6 equals 0. And at this point, I'm going to go ahead right here. I'm going to cut that member, and I'm going to use free body diagram down below. And we already know that F6 equals 0, so we've got F5. Right? This is a two-force member. So on the diagonal, that's BE. So there's our free body diagram. And this is going to go pretty quick. Why don't we sum moments at the cut? So we'll do it right there at the cut. And there would only be one force that's going to contribute. We would have F5, and I actually didn't specify, so I'm just going to call it D. And so its perpendicular distance would be D prime equals 0. Either way you slice it, we get that F5 equals 0. So we've got 0 for those two, so all we have left now is this free body diagram. And down below we've got F4 and F3. And so I can sum moments, and I'm going to do it up here at B. That's 8 feet. Sum of the moments at point B has to equal 0. That would say that F3 times 8 feet equals 0. There'd be a negative sign that would be going in the negative direction, but that would tell us that F3 equals 0. And we're going to sum forces in the y direction. That would give us minus 10 kips plus F4 equals 0, telling us that F4 is equal to plus 10 kips or 10 kips up. So after all that work, we actually find out that our solved free body diagram looks something like this. All the rest of those reaction forces were equal to 0.